alrighty then, seems like I'm live. So what I wanted to do today, I even wrote a guide to myself. I want to finish, actually I want to continue learning about deep learning, and I have these 3 chapters that I want to finish. Also, I decided to start preparing myself for possible business opportunities. So I'm gonna go back to coding. I'm gonna do some lead code examples, and hopefully I will have some extra space to squeeze something else. Okay, let's start with deep learning first. Let me just show my, oops. So what I did last time was I talked about derivatives. So again, derivatives are important, and derivatives can be depicted in multiple ways. So basically what a derivative is a way to show the rate of change of a function in respect to the input. So how does this work? So I wrote this function here. So this is how we calculate how much the output of f changes as we change its input at a particular value of a. So we have the value a that we produce the output. So we add an infinitely small number here, so we can compute the derivative. So basically in the end we'll get the rate of change. Okay. Another way of looking at derivatives is through the lens of a diagram. So I have this line here. I have a representation of a function here in the x and epsilon coordinate system. And I'm calculating the slope of this function by getting an infinitely small number that is smaller than our base number, but by a certain value, then bigger, and then we calculate the function there. So this is how we can show derivatives in a diagram as a slope. So wait, what do I have here? Just a second. So I can also think about functions as mini factories. So we have an input here, here, and we provide an output here. Okay. And the thing that I should continue doing is, just a second, let me open Visual Studio. Yeah, so what I want here is to create a markdown saying So how did I edit this one? Ah, it's double the hashtag. So derivative code, and I can put the code here. Okay, just a second. So okay, so now what I should write is the following: from typing import list. So now I'm coming here. So what we are gonna do now is define a data type for nested functions. So array function callable all right, and next we have chain, which is a list of array functions. So is this working? Why not? Okay. So why is the name callable not defined? Let me check. This is a Jupyter notebook. Is it a lowercase? I need to import it from typing. All right, so this was my mistake. Maybe I can import them just in this snippet here. Okay, run all. Okay. So what do these two lines do behind the scenes? So we create a type alias. This type alias will be used as a shorthand name for a particular type. In this case, the stuff on the right. This just simplifies writing, and also, of course, clarifies the purpose of the code. But okay, so now what's this here doing? So this one is saying, okay, next time when we annotate array function to something, please, what happens here? This is a callable. It's a function that takes one argument of type ND_array, and this is NumPy's multi-dimensional array, and it will return an ND_array as its output. So okay, these are just type annotations. Takes one argument of type ND_array, but this is an array. Okay, so I'm not very sure about the syntax, but okay, so function takes this, returns this. Now here we create another type alias. Okay, what's gonna be here? I have a list where each element is a type, is a function matching this type. Okay. All right, let's go back to the book. So oops, it seems like I jumped ahead in the book. So here I only need the callable. I don't need this code. Okay, my bad. I was thinking of why we talk about chains and we still haven't finished the derivatives, but this is how it should be. So I'm creating a function which is of type callable. Okay, and the array I'm not done yet. So what I'm gonna do, I'm gonna have an input of type ND_array and a delta, which is a float, being this. It produces an ND_array. So what's good? This, what will this do? Delta, then minus function input minus delta. Two times delta. Oh no, oh no, oh no. I forgot my tablet's on. Okay. Okay, so now this is the code. I created a derivative function. Now, let's talk about nested functions. So I think I understand these concepts pretty clearly. So I'm just gonna do here and save. I finished derivatives. Now, so in order to understand neural networks, there is a concept that I have to understand, and it says functions can be nested to form composite functions. Okay, so what does this mean? Okay. Can I open this again? Just a second. Okay, so let's talk about what size is this? 15. Okay, nested functions. All right. So if I have f1 and f2, the output of one of the functions is becoming the input to another. So if I have an x and it goes here, and then it goes here, and I have an output y. So these boxes are just way to represent nested functions. Okay, so an input goes into the first function, gets transformed, and comes out, and goes into the second and gets transformed again, and we get our final output. So how does this look from a mathematical standpoint? So I have f2, which takes f1 of input x, it gives back epsilon. So because these functions are read from inside out, basically meaning that we first applied this and then we applied this. So this is the first and this is the second. Now let's go back. Let's talk about code. And this time I won't forget to turn off my tablet. Here it is. Okay. So this is gonna be nested functions. And just as last time, I'll try. Okay, this is too much. Oops. Maybe now. Okay, just as last time, I'll try to go through this. So array function is a callable, takes an empty array, produces an empty array. So this basically callable means that this is a function that takes an ND array as an input and returns an ND array as an output. And now we have the second type, which is the chain. It's a list of array functions. All right. So I have these two types. Now I want to create a chain of length 2, takes a chain as an input, takes a ND array, produces an ND array. I have to make sure that the length of the chain is 2. Length of input chain should be 2. What else? Function 1 is the first element. Function 2 is the second element. Let me just scroll this down. Only difference is this needs to be here, and then I return this. Okay. No, this should be X, and this should be double equals. All right. If I save this, run it, nice. So what does this mean for me here? So is this just a single function, right? If I take X, I provide it to a box which is a representation of a function. I just have this here, and then provide epsilon. All right. So now we have these two functions, and they come together on the topic of derivatives by the fact that we can think of this function as just another function we can compute derivatives, a derivative of it. So computing derivatives of composite functions will be essential for training deep learning models. However, we need a formula to be able to compute this composite functions derivative. All right. Okay. Sorry, I was just getting some water. So we need a formula to be able to compute this composite functions derivative in terms of the derivatives of its constituent functions. Okay, this is the next topic in hand. I'm just gonna wrap it up. Okay, so let's talk about done. Let me just change the colors a bit here, and here maybe a red, so I can use it to showcase important information. So what's this? This is the chain rule. So what is the chain rule doing? It's a mathematical theorem that lets us compute derivatives of composite functions. Okay. Compute derivatives of composite functions. Okay. What does this mean? Deep learning models are mathematically composite functions. I didn't know this. So what if they are composite functions? And reasoning about their derivatives is essential to training them. Okay. So how does the math work for this? If I have a value, okay, we have a value of x, so let me just write this here. So it's derivative of f2 minus derivative of u of x is equal to what? A derivative of f2 over du of f1 x times the derivative of f1 over du of x only. So what does this mean? So u is a dummy variable representing the input to a function. So what does this mean? I have no idea. Just a second. Okay, so the chain rule is a formula that helps us find the derivative of a composite function, which is a function made by combining two or more functions. It helps us understand how the rates of change of those functions combine. Okay, so what's a composite function? I already know this, so it's that we first apply one function, then we apply the another one. So this is the chain rule right here. So what means this? It means take the derivative of the outer function and we leave the inner function unchanged. This is the first derivative, and we multiply this by the second one, which is the derivative of the inner function. Correct. Okay, so so I can find the derivative of h of x, which is the So there's a real world analogy here. So maybe I'll understand this better. So we have two machines, A and B. Machine A will double an input. So is this. And machine B is gonna square the input of machine A. So it's gonna be f of x, which is g of x, is 2x squared. So what is the chain rule telling me is how the final output changes when you tweak the original input. How fast does machine B change its output for a change in its input, and how fast does machine A change its output for a change in x? And we can combine the two rates. Okay, so this is how how changes propagate through layers of functions. Okay. Okay, so let me just do another example. So let's say I'm baking a cake and the temperature of the cake, so if I have a cake here, so let's say this is a cake, and so it depends on how much the temperature of the cake, it depends on how much time it's spent in the oven. So this is like, I have no idea how to draw this. So this is like the oven. Okay, with some knobs, it looks similar. And the temperature of the oven depends on how much you turn the knob. So turning the knob will change the oven's temperature. So it's G of n. And the cake temperature depends on the oven temperature. So this is the temperature, which is based on f of O. So what's the composite function? Is t equals f, like this. So how much will the cake's temperature change if we turn the knob a little? So this is where this algorithm will help us most probably. Oops. All right. So how fast will the cake react to changes in the oven's temperature, and how hotter the oven, the faster the cake will heat up, and how turning the knob changes the oven temperature? Okay, this makes a lot of sense. Suddenly a lot of things are clearer here. Okay, so we have another example. Okay, okay, I like this. I like this. I like this. So let me just remove the cake analogies here. So this is the chain rule. So what will happen here? What will happen here? So the derivative of the composite function should be a product of the derivatives of its functions that make up the composite function. Okay. So wait, there's another analogy. I have the function here, and I input 5, and I produce 1. Then I have another one. I input 1, I produce 4. So I have this, which are the two functions changed. I produce 5 and I get 4. Okay, but what if the derivative of this is 1 and the derivative of this is 3, and here I have 1, let's say -2. So how is this working? Wait, so okay, let's say we feed the value 5 into the first function. So this is value 5. Into the first function, and if we compute the derivative of the first function at a certain value, will give us a value of 3. So the derivative is 3. All right. And let's say we get a value which is 1, and compute the derivative of the second function at this value, and we find that this is the derivative. So what is this meaning? Okay, so the input, this will change the output rate to -2, and this already has the output rate of 3, so I can multiply this by, and I'm gonna get an output rate of -6. Okay, let's code this. So what will this be? This is the chain rule. Okay, let me just take, I'm continuing in the moment, let me just take a quick break. Okay, I'm back. So let's write the chain rule method. I'll just do here because I want to see had a break at 0, 43, 30. Yeah, I just want to write so I can, where I have these breaks, so I can cut them out of the video. I'm gonna move this here so it doesn't take the space. All right, so the chain rule. So I'm gonna use two functions here. The first one being the sigmoid function, and it's providing an array, so it's gonna return 1 over 1 plus this, I have a chain, I have an input range, produces an, and the array as an output. So this will use the chain rule to compute the derivative of two nested functions. All right. So let me just do some assertions. Requires two functions. What's the second assertion? Okay, assert so this should be input range. Requires a one-dimensional and the array as input range. Okay. Okay, oops. So what I have here, so I have f1 is the first element in the chain, f2 is the second element in the chain. The input range, it's a derivative of input range. So where do I get this function from? Ah, from here. Okay. So now this is a derivative of I1 and input range. All right, so now and the second one will have sigmoid and square. Let's plot these guys. Okay, so I'm missing these two functions. Let me just see if I can copy them from somewhere. Maybe from here. All right, so maybe I can add a code here to this, and then also copy this. I'm gonna hopefully go over all of this as soon as I finish writing it. I just want to make sure it works. And now if I run it, this should be chain 2. Something doesn't work. I need to import some more stuff. Just a second. So it's not just a second. So it's not a range, it's a range. Now if I run all of this, plot chain, where's the plot chain? Ah, so this is not defined. I also have to define these guys. So it's this method. All right, so I think this should be this. I should move here, and this should be here, I assume. And now if I run all, what are you saying? Plot chain missing input range. So I should also copy this. Now this is becoming a bit complex. So what's this? This is the plot library. I'm just gonna reduce, okay, this a bit. So if I run all now, I have here. Why? Where is this line? 35. But I saved you. Now run you. 35. Haven't I saved this already? Do I need to reload? Ah, no module name matplotlib. Alright, so this is where the cookie crumbles. So I think I just need to pip install it, right? Let's install it. Okay, this is installing. I'll be right back. All right, so I need to install matplotlib. Will this work again? Hopefully it does. It does. Nice. Now if all will work, no, it doesn't. Okay, but I have something here. Where's the first error? Here on line 36. And then I have another one here. Oh. Where are you? Where are you? Here should be one, right? If I run everything now, okay. What is this? The correct output? Is this what I want? So I'm also gonna copy this as well. this. Let's run all of this. This shouldn't be right. Seems like I might have mistyped something. This was copied directly, so I think the only issue where it might appear is this one in the chain rule. I think I already have the square somewhere. I have it here. So I have the square and I have the sigmoid. So the here is F2 and this will be F1 of the input range. Okay, I have now the same graphs as in the book that I'm following. So how is this working actually? Now that's what I want to do. I'm missing here. The legend. Let me just reduce this a bit again. All right. Okay, I think this is a good enough spot to stop this, and I'm gonna come back and continue doing my deep learning education course. But now let me go back to HackerRank or whatever else I wanted to do. I wanted to do the following thing. LeetCode actually, not HackerRank, it's LeetCode. I should oblige then. So I just created an account here. Can I remove this? All right, let's do two LeetCode examples here. Let's do two LeetCode examples here, but how is this working? So top interview 150. All right, let's start with this and remove element. Including that. Okay, let's enable this. Enable this. Toolbar, a central hub for key tools such as run, code, submit, notes, and other. Oops. Toolbar, I have tabs, I have resize panels, I have maximize a panel. I can do this, I can do that, I don't care. Okay, I want to increase this more, maybe too much. This is exact the amount I want. So we have, can I just, I think I, so what do I have? I have these languages. Let's use Python 3. I don't usually use Python 3. I use TypeScript. Is there TypeScript here? Yeah, it is. So, but I'm gonna use Python and maybe both Python and TypeScript. Okay. Bam. Before I start, let me just do something. All right. So, are there any tips for this? I mean, are there any tips in how LeetCode works? So, given an integer array, nums, and an integer val, remove all occurrences of val in nums in place. So, what does it mean in place? It's an algorithm that operates directly on the input data structure without requiring extra space proportional to the input size. It modifies the input in place without creating a separate copy of data structures. Okay. The order of elements may be changed, then return the number of elements in nums which are not equal to val. I haven't understood anything. Okay, I have nums, and I have an integer val. Remove all the occurrences of val in nums in place. Okay, so I also have tips here. So what should I do? I should change the array nums such that the first k elements of nums contain the elements which are not equal to val. Change the array nums. Okay, such that the first k elements of nums contain the element Okay, there are some assertions. And we have some constraints. What? Okay. What do the constraints mean? This is my first time using something like this. So what do the constraints mean? So these are the topics, arrays and 2 pointers. We have companies that are using it. We have hints. Okay, I don't want to use hints yet. Similar questions and discussions about this. So the first one means that the length of the array nums can range from 0 to 100. We have empty, we have exactly 100 elements. These values can be from 0 to 50. Okay. Okay, let me just open my tablet. Let me copy this. Okay, so yeah, let me write in the same one. I'm gonna, maybe not, maybe I could create a new one, sorry. Yeah, I'm gonna write it here. Let me just open it. All right. So I need to modify the array in place, and I need to have 2 pointers. Okay. Okay, so it's okay. Let's do this. All right, so what should I do? I should have like 2 pointers to iterate through array, 1 pointer to iterate through it, and another one will keep the track of the position where the next valid element should be written. All right, so let me do this. Where is the example? So I have here 0, 1, 2, 2, 3, 0, 4, 2, and the value I want to remove is 2. So I'm gonna start from here. I'm gonna do a for loop, blah blah blah. I'm gonna come here. All right, at index what, 2, 0, 1, 2. Let me just think about it. So I'm going here through all these numbers. If a number is not equal to this, I can write this number immediately, but because it's not here, okay, I think I know what's this. So I can do something like this. Index to right 0, so this will be the pointer. Then I'm gonna do this. Oops, sorry, let me show you what I'm doing. Okay, so I have this. I'm starting from the beginning of the, going to the end of the array. If element at this index is not equal to this, index to right is equal to this, then I'm just increasing this, and I'm this, and I think, how can I run this? Run. Please verify your email address in order to use our account. You must be joking. Just a second. Let me verify my address. All right, I hope I verified it. Now if I run, but I verified. Can I reload? Will everything be saved? It will. Okay, so if I run this, if it doesn't work, it works. It works. It works. Okay. Okay, I just wanted to see how this works. So I'm sorry, I need to end this now, but thank you so much for watching. And